Because what we're going to do is pretend to write a pre-lab for this rocket experiment. Does that make sense to you? Okay? Now, typically speaking, if you were going to write a pre-lab, I would give you something to go home and read it over, and just like those experiments that you were doing, Head Harry, Metallic Mike, and the cheese experiment, you would go through and highlight the IV and the DV, the controls and constants, and pick all that information out. Then you would sort it into this format. But we're not going to be launching ours up in the air. We're going to be launching ours for distance. We're going to put it on a 45-degree angle, right? This is straight up and down. That's 45. You can tell by that. And it's going to be launched out that direction. Does that make sense to you? Okay, so we're going to be going for distance instead of height. Okay? Your rockets will all be identical to this. You'll have a fuselage. You have 3 wings, precisely in the same format these are. You'll have an elongated nose cone with the circular nose cone here. You'll have a ping pong ball that's glued with a small piece of string. What that is designed for, as this goes through the air, what we don't want it is just to barrel down on the ground because it'll break, right? Well, as it starts going down, this thing goes like this and messes it up and actually makes it land on its side. Does that make sense to you? Okay. So it's being held in place, but I'm going to pump this up, fill with air, and then I pull this pin. The air wants to rush out of that hole, pushing the water in front of it. Does that make sense? And if you know anything, remember Newton's laws. For every action, there's an equal and opposite reaction. So the forcing down of this water will make the rocket go that way. That's how it's going to take off. The only thing that you're going to control is the amount of water we put into it. Okay? I'm going to put in 40 pounds per square inch of air. And the reason I know that is because on my little pump here, I can gauge that precisely. You all get the same exact amount of air. What you all have control over is the amount of water you're going to put in there. Jay Hunter, what is my independent variable?
The amount of water.
The amount of water. Okay? The amount of water. Does everybody agree with that? It's the amount of water. Now, Stephen, because I changed the amount of water, what do I hope changes because of that? The distance it's going to fly, or distance it travels. It's okay to word it differently. Those are pretty simple, right? Good. So I'm going to change the amount of water. And your idea of what's good or bad could be different. What is your hypothesis? How much want you to pick a specific number, like a fraction number? If I said 1/2, what do you said more water, so what do you think? 3/4? 9/10. Okay, so Reinhardt thinks that he wants to fill this almost up to the top. And I'd still pump it full of 40 pounds per square inch. Who's got a different hypothesis than that? Yeah, Max.
Like a quarter full?
I think it's a quarter full. Okay, what about you?
I think half.
The title for all your labs are going to be structured like this. Look up here, okay? The effect of whatever my independent variable is on the dependent variable. It's going to change per experiment, right? Whatever experiment you're doing, we happen to be working with a rocket here. So, we've already said what our independent variable is and our dependent variable. Who can complete this sentence for me? The effect of the independent variable on the dependent. Johnny.
The effect of the amount of water on the distance that the rocket will fly.
Does that sound good to you? It sounds good to me. Let's write that in right now. Okay? What you're going to do tonight is simply read over these rocket instructions here, the assembly of it. Okay? All I want you to be able to do tomorrow is come in and have a really, really good idea exactly the steps and the stages that you're going through. It is not rocket science. It's not rocket science, sort of it is, but you're going to construct these, and I really want you to be able to know what you're doing. I don't want you to get in here and have to play catch-up by reading this. So tonight, you're going to read this, have a good idea what's going on, so when you sit down tomorrow with your partner, we'll talk about that when you get in here tomorrow, you'll have an idea. Everybody's almost done filling up. Yeah, you need some glasses. Both of you need some goggles.
Change it.
That's too much.
Get your goggles on, guys. Sorry, I had to do that.
How are we doing here?
It's not on. It's not
That's perfect.
Come on.
I just gave you one, didn't I?
Yeah, that's not way.
In the lab, when we got there, I need you to treat it like you're in the lab. Okay, you're going to act professional, and we're going to take you 2 guys at a time. We're going to launch them. Everybody else will be standing off to the side, just paying attention. if for some reason you can't handle it, you're going to come back in the room and sit down and not a good chance to enjoy and watch these launches, man. I know you look great. Just give you guys a heads up about that. We're going to be walking across this road right here. When you go past the cars, you need to make sure you look both ways because these are high schooler guys going back to work in class. Okay?
Right, on the fold. No, you tape it on the fold. Tape it on the fold. You don't have to tape it.
All right, here we go. 3, 2, 1.
Lift off!
Boom.
There's a wing.
All right, going out to it next.
Come on!
I only got one chance to this thing is gonna
Go straight! That's like the second hole.
Tell me how it flew. I want the same thing for your rocket. Did it just go up and out straight, or did it curve to the right, did it curve to the left, did it spin over, gently come to a landing? One sentence describing that is something else I want you to go in. Right? Synopsis of what you did and the results in it and your conclusions from those results. But right now, before we can get into that, you have to make sure that you and your partner have this information. One, the amount of water that you put in it. And now you're taking that amount of water and you're making that into a milliliter. Okay? You also need to know how far it flew just now, which you all should have already, correct? And the last thing is you're going to think about right now and write a one-sentence description of how it flew through the air. Did it curve off to the right, did it spin? As best as you can, being as descriptive as you can. That's what I want you to do right now. And then you need to put that in your notebook so you can refer back to that in a couple days when we sit there and we talk about how to write this conclusion paragraph that's going to be the synopsis of your